Hi guys, today I'm going to talk about one of the important science topics for 9th standard, which is work and energy. Now friends, observe these images that I'm displaying very carefully. Let's categorize them into set A. Now observe these images and let's call them set B. Now I'm going to display images from both set A and set B. Guess the difference, the major difference between both these sets. So as we can see, objects in set A are moving, whereas objects in set B are still. Therefore, we can say that when object is moving, that is, when it changes its position, it is said to be in motion. We come across many objects in our day-to-day life that are in constant motion. Even all the planets rotate around themselves and revolve around the sun and are in constant motion. So, for an object to be in motion, an external force needs to be applied on it and the object needs to get displaced, that is, it has to change its position. Now let's see a few examples on this topic. Mike is moving his toy car. Is he applying force on the toy car? Is the car getting displaced? In the second scenario, Ishan raises his book. Is Ishan applying force on the book? Yes. And is the book getting displaced? Yes. In the third scenario, Fatima is standing with a book on her head. Is she applying force on the book? Yes. Is the book getting displaced? No. And in the last scenario, Nina is trying to push the wall. Is she applying force on the wall? Yes. But is the wall getting displaced? No. So as we can see in above examples, force is being applied on all the objects, but not necessarily all the objects move. So let's explore more about this in our lesson, work and energy. So, by definition, work is said to be done if a force acts on an object and the object is displaced. Now, if we recall our previous examples, in the last two scenarios, the object doesn't move. That means work has not been done on the objects. Now, let's consider an object at position A. When a force F is applied on an object, it moves by distance s to reach position B in the direction of force applied. So in order to find out how much work has been done, we use this formula. Work equal to force into displacement, that is W is equal to F into S. And the SI unit of work is Newton meters or joules. Now friends, let's consider a car. An external force F is applied on the car and the car is displaced by S. As you can see, the frictional force F is acting in the opposite direction to the direction of motion of car. So, work done on car by external force is F into S. As you can see, angle between frictional force and displacement is 180 degree. Hence, work done by frictional force is equal to frictional force into negative S. The negative sign indicates that frictional force and displacement are in opposite direction. So, work done by external force is positive work, whereas work done by frictional force is negative work. Now let's take another example. As we can see, the displacement S and gravitational force G are in opposite direction and are at 180 degree. So the work done by gravitational force on the given block is negative work. Now let us solve some problems using the formula that we just learned. A force of 10 Newton acts on an object. The object is displaced through 2 meters in the direction of the applied force. Calculate the work done. So our formula is W equal to F into S. That is 10 newtons into 2 meters, which is 20 joules. Now let's move on to the second problem. A force of 7 Newton is acting on an object. The object gets displaced by 1 meter in the direction opposite to the direction of applied force. Calculate the work done. So, a force of 7 Newton has been applied and the object is displaced by 1 meter but in the opposite direction. That is, negative work has been performed. So, our formula would be W equal to negative F into S, which equals to minus 7 Newton into 1 meter, which is equal to minus 7 Newton meter or minus 7 joules. So the work done here on the object is minus 7 joule. So friends, let's summarize what we have learned so far. Work done is equal to force into displacement. Now, when force and displacement are in same direction, it is called positive work. And when force and displacement are in opposite direction, it is negative work. Now, try answering these few questions. When do we say work is done on an object? Define 1 joule of work. State whether work is done or not in the following examples. Give reason to support your answer. So in the first scenario, a boy is playing with football. Here the object is moving. So work is done. Here Kathy is reading a book. The object has not been displaced, so work is not done. In this case, Tom is dragging his sister. He is applying force on the cart and the cart is moving, so the work is done. Here, Bonnie is using a computer, but the object is not displaced, so work is not done. In this example, Jack is working out. The object is being moved, so work is done. How much work is done if 4 newtons of force acts on an object and displaces it by 20 meter distance? Please solve this above problem by the formula that we learned just before. You should get an answer 80 joules. For homework, list some activities or examples of work done from daily life and state whether the work is positive or negative. Thank you guys for watching my video. Do not forget to like, share and comment. Also, please subscribe to my channel and Click on the bell icon to get notification.